So our next speaker is Rick Mohr from University of Tennessee. Rick is a senior systems architect at storage team lead at University of Tennessee's National Institute for Computational Sciences. He has 16 years of HPC experience with more than 7 years with Lustre. And he currently maintains the site-wide file system at NICS, and he also works with the CADES team at Oak Ridge National Lab for deploying storage resources. Rick?
So today I'm going to be discussing some of the work I've been doing with Lustre management with Ansible for the CADES project. CADES is the Compute and Data Environment for Science. It's an effort of the Oak Ridge National Lab to centralize some of their data and compute platforms. Right now, they currently have 3 primary Lustre file systems, one for each protection zone. They have one for open research, moderate, and one for HDSI. The zones incorporate various types of systems. They have VM infrastructure, cluster compute, specialized HPC resources such as Cray Eureka GX, SGI UV300. They've got compute clusters that are Cray CS400. And a self-service OpenStack environment. So they do quite a few things. Now when we talk about Lustre administration tasks, for the most part, when you're working with Lustre, the things you do on a daily basis, I think tend to fall into 2 kinds of groups. One is sort of managing the node states. You worry about, do I have the right config files in place? You enable, disable services, install, uninstall packages. You're looking to make sure that all your nodes are, consistent, and basically aiming for a static state. You want to know, you describe what your nodes look like and have them make sure they're in that state all the time. The other tasks is a bit more dynamic, involved in managing the file system. Many of the tasks are similar to managing the node states. You want your servers to have a consistent image, but there's a lot of runtime administration. You have things like MDTs, OSTs fail, so you need to fail them over. Maybe you need to disable an OST if it gets too full. And you have a lot of one-shot tasks. So you format the file system when you first stand it up, but you don't do that every day. So we're looking at using Ansible for these tasks. And Ansible is a great tool for the tasks that are in the first column, but it's not typically a tool you think about for tasks in the second column. So why are we trying to use it for both? Well, obviously, it's a great configuration management tool for the node images. In particular, it has support for chroot environments, and I'll get into that a little bit more in a few slides. Under the hood, it's using SSH, so it's kind of like a fancy PDish. And if you have a lot of homegrown Lustre scripts, probably that's what it's using under the hood, SSH out, mount all the OSTs, things like that. And what we're looking for is a way to, if possible, avoid duplication of information. If you have put information in your homegrown scripts, as far as which OSTs are on which host so you can mount it up, that same information could be useful for your node configuration state and things like that. So why not have the same tool used for both? Now, as far as Ansible for node administration goes, first I'd like to talk a little bit about how we run the systems in CADES. We tend to use diskless systems. They utilize kind of a hybrid shared NFS root file system that allows our systems to have a consistency between all of the nodes. It's stateless. In particular, we use JEDI, the generic disk installer, for this environment. And so what it's set up to do is you have a NFS, root file system image, mounted read-only, but then some RAM disks are created, and parts of that file system, like Etsy or whatever, then get copied into memory. Particularly, and then you have things like var and temp. Those also have RAM disks created. And the certain pieces of the file system that need to be customized at runtime, there's JEDI scripts that'll do that. Network interface config files, things like that, that might be slightly different across the nodes. Those files, initial files are copied into etc, and then a script will run and make tweaks to those and customize them or generate them on the fly. Now, so JEDI creates the basic root file system image on the NFS server, and then we use Ansible to basically manage that image. It lets us customize it. You've got, you can create repeatable environments. And the nice thing about Ansible is it has provisions for these chroot environments. Unlike a lot of other management tools, things like Puppet Chef might require extra modules to do it. For Ansible, it's very simple. When you, instead of specifying a host name that you would SSH to, your host, now becomes a path on the file system. And you can tell it that the transport is basically chroot into it and then do all this stuff. One of the drawbacks of this is that some Ansible modules utilize sudo TTY functionality of SSH, and so they're not compatible with chroot. Some of the examples are the service and command modules. A general design for our playbooks is we try to divide up roles by the most general to most specific in order to allow optimal reuse of our code. For examples, we have roles for the base NFS root configuration that are shared by Lustre and compute nodes, and then we have additional roles that specialize that depending on whether it's a Lustre node or a compute node. The roles that are used, if you have any roles that you want to use on both sort of normal and NFS root-based servers, you might need to take some extra steps to make sure that they'll work in both. An example of this is a LDAP configuration. Some hosts, we just normally have Ansible go out and directly manage that configuration in the chroot environment. What we had to do is actually do sort of a kind of a one-off thing, and rather have it go in and make a direct change. There's a script that encompasses those changes, and so when this module runs on a normal host, it will copy it over into temp, SSH over, run it. If you're in the chroot environment, it copies it in there, chroots in, and then runs it. So that way it works the same in both cases. Here's a very abbreviated example of what one of our playbooks looks like. Here you see the host. We give it the path to the image. The connection is chroot. And then some of the roles that we put in there, you can see they go from general, you have your base authentication for LDAP, you set up host files, and then they get a bit more specific, and the naming convention even reflects that too. You have base underscore something, and then when you start getting to things that are directly related to storage in a particular Lustre, they're named storage underscore Lustre, whatever. So then we have playbooks that do specific things, configure the ZFS repo, configure SRP, things like that. And I won't show the exact details of these roles because in general, these things are going to be site specific anyway. And so the things that we do in CADES don't necessarily apply to you, but this kind of gives you a general feel for how we manage some of these root file system images. And that stuff is pretty standard. If you've used Ansible and you're managing hosts, using it to manage these chroot images it was pretty easy. There's nothing really that different about managing these chroot images with Ansible. The place where we start to deviate a bit is when we start talking about Ansible for Lustre administration tasks. This is the area that is probably not what you typically think about using Ansible for. We're not talking about defining a known node state and then repeatedly running this playbook every hour to ensure that all nodes are in that state. We're talking more about dynamic tasks, one-off things that you'll do when you first set up the system, or you only do them when a certain event happens. And so here's where I'll throw my disclaimer that I am not an Ansible expert. I'll show you the work I've been doing is very much a work in progress. So some of the design decisions that I present here may not be final as we continue our work on it. Some of the choices I have are sort of site specific now, and I'm hoping to generalize it in the future. And there are certainly some edge cases that I have not tried to look for and error checking that needs to be added to it. But my goal is to hopefully generalize this work as much as possible and make it into something that could be used by others. And feedback from anyone who does have more experience in Ansible is always welcome. So for the Lustre file systems in CADES, we've been setting up ZFS-backed Lustre file systems. So some of the admin tasks that I typically had to do when working on this is managing Z pools, create, destroy, import, export, what's the status of them, and then as well as managing the Lustre targets. You format them, you want to start and stop them, you need to be able to handle failover, etc. And sort of the overall general design for a lot of these plays and roles is that I tried to use roles to group the tasks based on functionality. Z-pool stuff is in one role, Lustre stuff is in another. Any host-specific parameters I put in the Ansible host vars directory, and default parameters go in the role directory in its vars subdirectory. I'm using tags to select specific actions, and I only want these plays to run when I specify a task. I don't want someone to accidentally fire up a playbook and format my Lustre file system. I want it to be a very deliberate action that you need to take. And we also support the use of limit to restrict actions to specific hosts. And if you actually want to restrict even further to specific targets, we use the -E option to specify additional variables. So an example with managing the Z pools. So in this case, for the config format, what we've done is set it up so for a specific host, you have a zpools.yaml config file, and in it you simply list all your Z pools. You can give them a name, and then you list the device. And here the device name is simple. We have DDN storage, so we have sort of one pool per LUN. And then the actual role itself, this is an example of part of one of the plays in that role. One of the first plays there is I set a fact abort equals true. That's done so that if someone just fires up a playbook, none of these plays will run by default. Nothing will actually happen to the system. So for the one play I have in here, this create a task to create a Z pool. You can see that it has the command, the Z pool create, with several variables that get filled in. The with items is used to loop over all the Z pools defined on all the hosts, and there's a conditional. It basically says only do this when abort is undefined, which means you had to jump straight to this play by specifying a tag, and also, make sure that if you specified a target on the command line, only do it if your item is going to match that target. And then I throw in a tag that create zpool tag, which is how you specify this. And then for testing, you can create a very simple playbook where you list your hosts with all your ZFS nodes and throw in the zpool role. And then actually using it would look something like this. Call Ansible playbook with the zpool.yaml playbook. And if you want to create all the zpools on all your hosts, you give it the tag create zpool, and it will go out to all your hosts and create all the zpools. If you just want to create zpools on a single host, you basically do the same thing, except now you specify the limit option and you give it a host name. If you want to look at things like importing that, I didn't show the actual play for importing it, but it's very similar to the one, creating. You specify the playbook, you specify the tag is import zpool, you can limit it to the host, and then there's also an example of using the -E option to specify a specific target. In this case, you say target equals pool name, and it will go in and import only that pool on that one specific host. So you have control over how much is done with each of these plays. Now, when we're talking about some of the Lustre tasks that are available, one of the things I'll show here is formatting the file system. Some of the configuration information we have is for the, in the host vars for each specific host, you're going to define, say, the OSTs, or if it's an MDS, the MDTs that are available. You give it the name of it, the index, and the Z pool that you're going to use for it. And then in the Lustre role itself, that's where you define certain default variables. In this case, the file system name, the backfs type, and the MGS node. And then for the actual tasks, this is an example of what formatting the MDTs would look like. Again, you have the command line with a bunch of variables filling in the details of the file system name, the Z pool that's being used. You loop over, in this case, all of the MDTs. And then you have your addition, your conditionals. You only do it if a board is undefined, so you have to specify the tag to run the play. Make sure the MDT variable's defined, because if you limit this to a set of hosts that don't actually have any MDTs defined, then it's going to error out. And if you want to limit it to a specific target with the -E option, making sure that the target matches, the item name. And then we define tags. In this case, there's actually two separate ones. One is a format MDTs tag if you wanted to format all MDTs, as well as a format Lustre tag, which would be used in any place that also format the OST, so you could format your entire file system at once. Again, we have a simple playbook that you can use to test this, where you just include the Lustre role, and then some examples of how this would be used. To format the entire file system, give it the tag, format Lustre. And so then the plays that format the MDTs, as well as the one that format the OSTs, those all get run. You could also just limit yourself to formatting all the MDTs by specifying a different tag. If you want to format a single OST, specify the format OSTs tag, and then give the additional -E option, say target OST 0. So you're only formatting that one specific OST. Or if you want all OSTs on a single host, instead of using -E, use the limit, give it a host name, all the OSTs on that host would be formatted. And similar sort of plays can be defined for starting all of your Lustre targets. In this case, the command is the mount command with options. Again, you'd have, with items, you loop over, say, all the OSTs. You have your conditionals to control when exactly the command's going to be run, and the additional tags. Start OSTs if you want one of those, as well as a general start Lustre to start up your entire file system. So starting your entire file system would look something as simple as specifying tag start Lustre, start all OSTs on a single host, give it the start OSTs tag, and use the limit again to restrict those commands to a single host. So this is just it shows you snippets of all the plays and stuff that we're working on. As far as future work goes, there's still quite a bit of it. This is still kind of, we're just getting started on this. There's definitely a lot of additional functionality and generalization that needs to be done. We don't have any support for LDiskFS. We've just been focusing on the ZFS since that's what we've been using. But it would be nice to add support for that as well, make it a little bit more general, as well as support for arbitrary layout for Z pools. What I showed here was very simple. It was one LUN was one Z pool. Well, obviously, you're probably going to want more complicated setups like that, multiple LUNs in a single Z pool, things like that. So we need to be able to support that, as well as be able to toss in information for specifying your failover parameters. It would also be nice to be able to support multiple Lustre file systems. Ideally, if you're managing a bunch of hosts, you might be having your same set of Ansible config files used to manage multiple systems that are part of multiple Lustre file systems. So we need to have a way that we can specify which file system we're talking about when you run these commands, instead of just having, as I showed in my example, a single default file system name that's used for everything. This might require us to investigate use of some custom VACs or modules to handle some of this stuff. And then we also want to look at how much of this we can tie into management of the root file system image. Some of these config variables and stuff could be used to generate, your lnet.conf, various things like that that tie into it. So they, even though that we define this stuff to be used for sort of Lustre administration tasks, that information is also used for some of these static config files as well. And so it'd be nice if we could tie those things together. In conclusion, we found obviously Ansible is a good configuration management tool for our NFS root images, mainly due to its support for the chroot environments. Although some small concessions have to be made for certain modules. And it also looks to be possibly a promising tool for Lustre administration beyond standard configuration management. These playbooks could help automate many of the Lustre tasks, but there's still work that needs to be done to generalize these things. And there's still some questions on exactly how far this work can go. Turns out as we add more and more features, the configuration gets more and more complicated, or the plays start having to twist themselves and jump through hoops in order to get it done. Maybe we find out that it just can't quite do everything we want to, and we have to resort to something more like a scripting language just to get that sort of control that we want out of it. But so that's still an open question and something we're looking at here. I will say that our plan for this stuff, while we don't have it publicly available yet, the goal is to finish up some of this work hopefully over the summer and then put something out there that other people can download and play with. So when we are in a position to do that and we have sort of code online and publicly available, my plan is to send an email out to the Lustre Discuss mailing list, letting everyone know the URL so people can begin sort of checking this out for themselves if they're interested. I'd like to acknowledge the use of the CADES resources at ORNL, supported by the DOE, and ask if there are any questions.
Thank you. Any questions?
I was wondering if you had any experience using one of the front ends for Ansible, like Tower or Foreman.
No, I personally haven't. I'm actually still pretty new to Ansible itself, sort of thing. There have been some people at CADES that have talked about looking into that. I don't know what their timeline is or plan is for checking that out, but unfortunately, I personally don't have any experience using that.
Any other questions? Thank you, Rick.